Alright, in the previous video, we started looking at some examples, and then we gave you these three to have a go at. Just note that there was a typo mistake here with the last one. This was presented as a plus here. This should be a minus, so you might want to have another attempt at that one with a minus here. Alright, for E, so we've got 2 cos squared 15 minus 1, and if we look at our double angle formula, we can see that it's just the double angle formula for cosine, which involves cos only. So if alpha is 15, then 2 alpha is going to be 30, so that's just going to be cosine 30, which is root 3 on 2. And then on tangent 75, again we make the use of the fact that 2 times 75 is a special angle in 150, so we're going to use the double angle formula for tangent, which is this one here, with 2 alpha being 150, and so then the unknown is this one. So just to make our work a bit tidy, we're going to let big T be tangent 75. So this side is going to be 2t over 1 minus t squared. Of course, the left hand side is negative 1 over square root 3. And then all you need to do is to solve for t, really. So you can rewrite this in standard quadratic form. And then use the quadratic formula here. And then we find two values here. One of them is going to be plus square root 3 plus 2. But square root 3 minus 2 is going to be negative. However, 75 is in the first quadrant, so we know that tangent 75 must be positive, so it must be the one with a plus. And then for this one, this got sine cos, so it looks like this trigonometric formula here. However, so on the first term I've got 80 and 110, in the second term I've got 110, but the other one is 280, so we need to make a link between these two. So the idea is to write 280 as an angle that is acute. So if we make a sketch of this, we see that the reference angle of 280 degrees is 80. So what that means is that we can actually write 280 as negative 80 degrees. Then of course it means cos 280 is cos negative 80, but since cos is even, is the same as cos 80, so that means this term here we can simply replace by cosine 80, and then of course using that formula for sine A alpha minus beta, then there's going to be simply sine 80 minus 110, which is giving us sine negative 30, and so this is going to be negative half. Right, we're now going to go to the second example. Right, in this example, we are given that cosine A is equal to negative 1/2, and that the angle A is in the second quadrant. Then want to find the exact value of sine A, cosine 2A, and sine 2A. And then from that, we want to state the quadrant in which the angle A is going to be found. Okay, so the first thing we need to do here is to make a sketch of our angle A. So it's in the second quadrant, so it's going to look something like this. So cosine A is -1 over 2, so that means we need to work out this value here. So we're going to have -1 squared plus y squared is 2 squared. So this is going to give us y squared is 4 minus 1. So y is plus or minus square root 3, but we can see in the second quadrant y is positive, so that's going to be square root 3. So from that it means sine A is going to be square root 3 over 2. Then sine 2A, we're going to use the double angle formula for sine 2A. So that's 2 sine A cosine A. We just found sine A to be root 3 on 2. Cosine A is given as -1/2. So this is going to be negative root 3 over 2. And then cosine A, 2A, we can use any of these formulas here. I'm going to use the first one, going to be cosine squared minus sine squared A, because we know both of them. Cosine squared is going to be -1/2 squared, and then sine squared is going to be root 3 over 2 all squared. So this is going to be 1 over 4 minus 3 over 4. So it's going to be -2 over 4. This is going to be -1/2. Then the last bit of the question, we need to say in which quadrant the angle 2A lies. Now, notice that if we have an angle in the second quadrant, so if A is here, then the smallest that A could be is 90 here, and 2 times 90 is 180. And the biggest that A could be is 180. 2 times 180 is 360. So that means if the angle A is in the second quadrant, then the angle 2A could be anywhere in quadrants 3 and 4. So the thing that we want to determine is whether our particular angle is in the third quadrant or the fourth quadrant. Now, we see from our calculations that both cosine 2A and sine 2A are negative. So that can only happen in the third quadrant. So 2A is in quadrant number 3. Okay, I'm going to give you the next question to try. Alright, so this is a similar question to number 2. So this time we are given that the angle A has got sine A being root 5 over 2. Cosine A is positive, so we want to find cosine A, want to find sine 2A and cosine 2A. And then from that, we want to determine the quadrant in which the angle 2A lies. So if you want to have a go at that, and then you can compare with our answer, which is going to follow in a while. Okay, just a small correction on this question. This denominator is supposed to be 3. Yeah, so please have a go at that. And yeah, then you can compare with our answer. All right, so we taking it that you have already tried this question on your own. So the sign of a is a positive number, and we're told that the cosine is also positive, so this number must be in quadrant 1. So since sine is square root 5 over 3, then that's the opposite, and that's the hypotenuse. So we need to find that adjacent, which is x. So Pythagoras gives us that x squared is actually 4. So x is plus or minus 2. But since we're in the first quadrant, it must be equal to 2. It means cosine of a is going to be 2 over 3. Then sine 2a, using the double angle formula for sine, is going to be 4 root 5 over 9. And similarly, cosine 2a is going to be negative 1 over 9. So sine 2a is positive, cosine 2a is negative. So 2a can only be in quadrant number 2. Okay, so let's now look at the next question. Okay, so this time we have tangent A being equal to 3 over 4, and cosine B being 12 over 13. A is in quadrant 3, B is in quadrant 4. We want to find sine of A plus B, cosine of A minus B. So we're just going to be using these addition formulas there. Okay, so let's see how this works out. It's going to be pretty similar to what we've done in numbers 2 and 3. The only difference is now we have got 2 angles happening. So one of the angles is in quadrant 3 and the other one is in quadrant 4. So we're going to have our sketch here where we're going to have lots of space for quadrants 3 and 4. So the first one is A, which is in the third quadrant. Now the tangent for A is 3 over 4. In the third quadrant, both x and y are negative, and so that means this must be 5. And then in the third quadrant we have got cosine B is 12 over 13. So we need to find y here. So this here is A. I'm just going to do B this way. So that's B. Okay, so let's find y. So by Pythagoras, y squared plus 12 squared is 13 squared. 13 squared is 169. 12 squared is 144. If we do 169 minus 144, we get 25. So this is 25 here. So that means y is either 5 or minus 5. But we can see we're in the third quadrant, so it can only be a minus. So what we can do now is to summarize all the values for angles A and B. So sine A is going to be minus 3 over 5, minus 3 over 5. Cosine A is going to be minus 4 over 5. Well, we can write tangent, but we're not going to need that because we're only doing sine and cosine here. Then for B, sine B is going to be negative 5 over 13. Cosine A, of course, is given is 12 over 13. So with that, we can now do sine of A plus B. So sine A plus B, so just using that addition formula there. So sine A plus B is going to be sine A cos B plus sine B cosine A. Then sine A is negative 3 over 5. Cosine B is 12 over 13. Sine B is negative 4 over 5. Cosine, what's going on here? This is supposed to be B there, of course. So sine B is negative 5 over 13 actually. 5 over 13. Cosine A is negative 4 over 5. Just make sure these are okay. So sine A is negative 3 over 5. Cosine B is 12 over 13, yes. Then sine B is negative 5 over 13. Cosine A is negative 4 over 5. So what we're going to have here is negative 36 over 65 plus 20 over 65. So it's going to be negative 16 over 65. Okay, then for the second one, we've got cosine A minus B, which according to those formulas, cosine A cosine B plus, because it's this one, the, okay, so that's going to be plus sine A sine B. So cosine A is negative 4 over 5. So we're going to have negative 4 over 5 here. 12 over 13. And then negative 3 over 5, negative 5 over 13. 3 over 5, negative 5 over 13. So this is going to be minus 48 over 65 plus 15 over 65. Then 48 take away 15 is going to be 33 negative in this case, so it's going to be negative 33 over 65. Right, so that's number 4. We're going to go on to number 5. Right, in number 5 we've got two trigonometric functions, trigonometric identities. We are going to do B and then we're going to give you a chance to have a go at A. So in B we have got sine of pi on 6 plus phi plus cosine pi on 3 plus phi. This we are told is equal to cosine phi. So we're going to start working from the left hand side. On the left hand side, using the addition formula for sine alpha plus beta, which we have here. So our alpha is pi on 6, our beta is phi. So this is going to be sine pi over 6 cosine phi plus sine phi cosine pi over 6, and then plus for the second one I'm going to use the addition formula for cosine, which gives us cosine alpha is pi on 3, beta is phi, minus sine phi sine pi on not pi on 6, pi on 3. And then just remember pi on 6 is 30, so sine 30 is 1/2 here, so it's going to be 1/2 cosine phi plus, and then cosine 30 is root 3 on 2, okay, then minus, and then cosine 60 here is 1/2. So that's not minus, that's plus 1/2 cosine phi, then sine 60 is root 3 over 2, then times sine phi, and then we are going to notice that these two here cancel out while these two add. So that means we're going to have cosine phi, which is the same as the right hand side. Okay, so if you want to have a go at part A says cosine 45 plus phi minus sine 45 minus phi is root 2 sine phi. Alright, so for that part A, we're going to have to use the addition formula for cosine, addition formula for sine alpha minus beta. So for this one, we're going to have cos 45 cos phi minus sine 45 sine phi, and then minus, safe to put this in brackets. So this one we're going to have sine 45 cos phi minus sine phi cos 45 because of the minus there. Then sine 45 is equal to cosine 45. They are both equal to root 2 over 2. So if plug in root 2 over 2 here, 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 and there, we're going to get root 2 on 2 cos phi minus root 2 on 2 sine phi. So there's these two terms minus. This one is going to be minus root 2 on 2 cos phi. Minus and minus, this one is going to be plus root 2 on 2 sine phi. Then the sum of these terms are going to cancel out. Just one moment. Which is, this is actually going to work out as follows. The cosine terms will cancel out and the sine terms will cancel out. So in this case, actually this should be equal to 0. So if we just go back here, make that correction there, that should be equal to 0. Okay, let's move on to the last question in this set of examples. Alright, in this example, in 5a, we want to express cosine 3 theta in terms of sine theta. In 3b, we want to express cosine 4 theta in terms of cosine theta. And then in the last one, which we're going to give you a chance to try first, we're going to write sine squared 2 theta in terms of cosine theta. Okay, let's look at the first one. So in the first one, we've got sine 3 theta, which we are first going to write as sine 2 theta plus theta. And then we're going to use the addition formula for sine theta. So our alpha is going to be 2 theta. Our beta is going to be theta. So it's going to be sine 2 theta cos theta plus sine theta cos 2 theta. Now remember, we want to write everything in terms of sine at the end of this. So in the next step, sine 2 theta, there is only one formula for that. So we're just going to write that as 2 sine theta cos theta. Then this is multiplied by cosine theta. Then cosine 2 theta, we want it in terms of sine only, so it's going to be 1 minus 2 sine squared theta. Okay, then we multiply out. First term is going to be 2 sine theta cos squared, because we've got cos here and cos there. Then plus, if we remove brackets here, we're going to have sine theta minus 2 sine theta cubed. So we almost have got everything in terms of sine now. It's just this term which is still in terms of cosine, but from the fundamental identity of trigonometry, we know that cosine squared theta is the same as 1 minus sine squared theta. So plus sine theta there minus 2 sine cubed theta. Then if we remove brackets there, this is going to be 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. Then collecting terms going to give us 3 sine theta being these 2 minus 4 sine theta cubed. So that is your sine 3 theta in terms of sines. Then in B, we're going to work out cos 4 theta. We want to write it out in terms of cosines. The way we're going to go about this is we're going to use the double angle formulas. So here, cosine 2 alpha is 2 cosine squared alpha minus 1. So cosine 4 theta is 2 cosine squared 2 theta minus 1. Then if we use the same identity, cosine 2 theta is 2 cosine squared theta minus 1 and then squared. Then if we remove brackets there, that is going to be 4 cosine theta to the power 4 minus 4 cosine squared theta plus 1. And then removing the square brackets, going to be 8 cosine theta to the power 4 minus 8 cosine squared theta plus 2 minus 1. So finally, this is going to be cosine theta to the power 4 minus 8 cosine squared theta plus 1. Alright, so now we're going to give you a chance to write sine squared to theta entirely in terms of cosines. Alright,